Hi there. I thought it might be worth just recording a little video to go over how we breadboarded our Winky Blink circuit for BCIT TTED 3060. It's a great little introductory circuit for getting students making circuits using breadboards and familiar with some of the common electronics components that we're going to use in a lot of our other projects. And so I've got laid out in front of me a Winky schematic and some of the parts. I'll go over what they are, and then we'll bring my breadboard in right here, and we'll look at how I'll put those parts onto the breadboard. But before we do, I want to take a moment and let you know about my favorite circuit simulator. It's online, and it's called Falstad's Circuit Simulator. And I'm just going to bring this up right here and make it go full screen for us here. And let me just bump that up to the top of the chart. And here we go. So this is Falstad Circuit Simulator. The website's falstad.com/circuit. And the guy who's written it has made it freely available for people to take a look at how various electronic circuits work. And I've got a link in your Desire to Learn file that'll take you automatically to a fully set up and running Winky Blink. But you can also go in there and design your own. So looking at this circuit, what we've got here is we've got our power supply, which is set to 9 volts. And to make the simulation go a little bit faster, I've changed these resistors down to 47 ohms instead of 470 and 5.6K instead of 56K. And that just means everything will go about 10 times faster. A little easier to take a look at. I've left the capacitors the same size in here, and we've got our transistors in here nicely laid out in their schematic symbols, and our diode leading down to the ground, and you can see our LEDs are turning on and off in here, and they're blinking really nicely. Now, just before we get too much into this, I want to go over what a few things are doing in here. And these resistors right up at the top, they are limiting the flow of current to the LED. If you don't limit the flow of current to LEDs, LEDs can burn out very, very easily. So if you just hook your LED up to a 9-volt battery, it will quickly become a DED, or darkness emitting diode. About the time all the smoke comes out of it, that's when that happens. So these resistors right here are protecting each of their respective LEDs by limiting the flow of current. These resistors right here are working with the capacitors that they're connected to, and these resistors are limiting the rate of flow of current into the capacitors because we're going to be charging and discharging the capacitors. Capacitors work like tiny little batteries in the circuit. So as you charge them, their voltage goes up, and as they discharge, their voltage goes down. There's a little bit more to it than just that, but you can think of that for now. We're charging them and discharging them, so their voltage goes up and their voltage goes down. And you'll see that sometimes we have current flowing through them this way, and sometimes they'll be discharging and current will flow out the other way. Finally, our transistors act as a switch, and they're a switch that is controlled by the base. So at this point in the circuit right here, you can think of that as having your finger on the base. And when you push in on the base, then you turn the transistor on and allow electricity to flow down through here. And when you pull your finger back from the base, representing a 0 or negative voltage, you turn this off. So really, we're sitting there poking that little transistor, turning it on and turning it off. But instead of using our finger, we're using voltage right here. And where the voltage comes from is the charging and discharging of our capacitors. Finally, we've got the diode at the bottom. And the diode is there because it's like a check valve on our electricity. If anybody were to ever hook the battery up backwards, the diode would protect the rest of the circuit. So the diode's in there protecting the circuit. And it also, when you're doing this with high school students, gives you a chance to talk about a diode and how they're a check flow for electricity and a one-way valve. And you get to see what the part is and spend some time talking about it. Now, there's a couple things you can do on here in Falstad to take a look and get an idea of what's going on the circuit. Try turning the current speed up high. And really, your charge flows at the same speed everywhere in a circuit, but because it flows with, there's different amounts flowing in each line, False stats use the speed of the dots to indicate what's going on. And you can see right here, let's take a look at this capacitor right here. You can see that it's charging up right now, and it's building up charge, and then when this transistor turns on, it's able to discharge right down here. And as this discharges with a flow through that transistor, that pulls this side down low or to negative, which turns this one off. So just keep watching there. It's charged up, it's almost finished, and then wham, this one turns on, it turns this one off. Then this capacitor right up here charges, this one turns on, and then that one discharges. And we alternate back and forth between charging this capacitor and charging this capacitor. This transistor's on, and that transistor's on. So one on, one off, one on, one off, and you'll see that Winky Blink taking place in there. There is more to it than that. If you try to wrap your head around it too much when you're new to electronics, you're going to get a headache and a pat on the back, and you're probably not going to understand everything that's going on. But if you understand that this capacitor and this resistor right here are controlling the time that it takes to charge right up there, and the time that it takes to turn one of your LEDs on and off, and this control the time it takes for the other LED to turn on and off, then you're going to be able to play around with some of those values later on and make it go blink, 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 or some variation thereof. You can make it blink fast, you can make it blink slow, you can play around with all those values. So I'm just going to leave this running in the background right here, and let me just shrink that window down and drag it out of the way while I go on to talk about a few other things that we've got going on. There's our schematic right there. And now you can see I've got a paper version of the schematic laid out on the camera right here and can talk about some of the components. So you're going to want to start out by going through your bag of parts, gathering up your supplies. And the battery right here, you could use a 9-volt battery for running this on your circuit. And if you're using the 9-volt battery, you'll have a 9-volt battery clip in your bag of parts. Right now, I'm doing this in the shop, so I'm going to be using my power supply. So I'm just going to have a couple of alligator clips right here hooked up to some wires that I can plug into my breadboard. All right, now our power comes in off the top and comes around this way, and it comes to these two resistors, R3 and R4. Now, on our schematic right here, it says R3 and R4 are supposed to be 470R, or 470 ohm resistors. So you can use your resistor color code, see if you've got a 470 ohm resistor. Really, if you don't have a 470 ohm resistor, you're running a 9-volt supply in there, I'd say anywhere between about 100 ohms to 1000 ohms is going to work just fine. Okay, 470 is nice and in the middle of all that, but what this is doing is this is controlling the brightness of your LED. So there we go. If you want a brighter LED, put a lower value resistor in there. If you want a slightly dimmer LED and use a little less battery, then put a bigger value resistor in there. But you can even put different value resistors on either side. You'll notice that I've got these resistors already cut to length. Since we're putting them into a breadboard, I like to just bend the legs over and cut about 1 centimeter of leg. I find 1 centimeter fits really nice into a breadboard. All right, come down here a little bit. You'll find 2 more resistors, and these are listed as a 56K ohm resistor. Now, again, these ones are being used in conjunction for timing with these LEDs down here. So using a different value resistor, your circuit should still work. It's just going to blink at a different rate. If you make it blink too fast, you won't see it blinking because it'll blink faster than your eye can see. And if you make it blink too slow, well, you won't see it blinking because you'll get bored and walk away before it makes its first blink. So somewhere in here, you could probably choose for these resistors in here anywhere between about a 10K ohm resistor up to 100K ohm. Okay, and that varies somewhat depending on the capacitor that you have right down here. Now the capacitors, again, I've cut their leads off, so you can't see which is the longer leg on the capacitor. However, the capacitors are what we call aluminum electrolytic capacitors, and they are polarized capacitors. So I'm just going to hold this up right here and focus in on that. And you can see that the polarized capacitors have a marked stripe on one side. And just in case you happen to forget that that's the negative side, they put a big minus sign on it. So if you're working with a aluminum electrolytic capacitor, something that looks like this, watch for that minus sign on it, because if you hook them up backwards and connect them to a high enough voltage, they can blow up in a pretty violent fashion. Now, the capacitors we have right here are radial capacitors, just the package that they're in is the name. You can also get an axial capacitor that looks like this, where the leads come out of either end of the capacitor. So you might have something like that kicking around. And if you take a look at that one, you'll see that it's got a minus sign on it and an arrow pointing to the negative side right here. So when you're dealing with the aluminum electrolytic capacitors, pay attention to the markings on them, and you'll also see values stamped on the side of them. So this one right here says it is a 47 microfarad capacitor. Zoom in on that a little tighter. Okay, and so capacitors are measured in farads. Farads are very big units. So micro means 1/1,000,000th of a farad. So we've got 47 millionths of a farad right there. The 63V that you see before that indicates that the capacitor is safe to use up to 63 volts. So pretty good for our Winky Blink, but I wouldn't want to go hooking that up to anything running off 120 volt house power or anything like that. Not that we usually use aluminum electrolytics with aluminum house power. You'll have other values of capacitor in your kit, but for what we're using today, you're going to find that we've got a 10 microfarad capacitor sitting in there. And again, keep your eye out for that negative side because the capacitors are polarized. These capacitors are. We have other types of capacitors that aren't. We'll cover that later on in the course. Coming down the outside of your circuit, you've got a couple of different LEDs that you can use. And I've chosen a red and a blue because later on I'm also going to build a siren circuit, and I'm going to flash my red and blue lights and have my siren wail at people. So yeah, right. Anyway, here we've got a blue LED, and here I've got my red one. And just a couple of things to note about the LEDs. Let me find one where I haven't bent the leads all out of shape on them. And this happens with the capacitors as well, but I'll zoom in right here. So when you're looking at your LEDs, you'll notice that one leg is shorter than the other if you've got a brand new capacitor. And that short leg, if you follow it up, should come to a flat side. So look at it from the bottom, okay, and rotate it around. And okay, is the camera showing that clearly? Let me just turn some light on here. Maybe that'll help it stand out a bit better. And there you can see up at the top is the flat side of a capacitor, okay, of an LED. Right along that edge where my fingernail is touching. My wife's maybe right. Maybe I do need a manicure. Anyway, that short leg should lead to the flat side, and that's going to be the cathode or negative side of your LED. And LEDs, like all sorts of diodes, are a polarized device. In other words, they only flow in one direction. So make sure you get it the right way around if you want your circuit to work. We come down here and we've got a couple of transistors. Okay, Now, there's a whole bunch of different transistors that are available for you to use, and not everything that comes into a package like this looks like a transistor. And for that matter, not everything that comes in a package like this is a typical LED either. There's some photo transistors that fit into packages like that. You can get infrared LEDs, which are LEDs, but because they're in the infrared, you can't see them. Anyway, if they're red and they're blue, you can be pretty sure you've got a red and blue LED right there. But transistors are a little bit of a different thing because they fit into a standardized package that's used for a whole bunch of different things called the TO92 package. And they do this to make the electronics cheaper to manufacture because they can have one standardized package for many, many, many different types of electronics projects. And I'm just going to hold this up here and point out what you want to be looking at on the face of that transistor. You've got to get the printing is quite faint sometimes. I've got to rock it around in the light to get it just right in here. And I'm almost too close into the light. There we go. I need to zoom in a little bit. Oh, there we go. I just about had it. There you can see right on the face, it says 3904. Let me zoom in just a bit closer and see if I can get a better picture of that for you. It's a little easier to see by hand than trying to get a great picture for the camera, but there you go. It says 2N3904 on there. Now, you're not going to know this off the top of your head. You might have to Google it to look it up, but the 2N3904 is a type of transistor known as an NPN transistor. And the NPN transistor is the one we want for this circuit because our schematic symbol right here is not pointing in. Okay, so not pointing in. So the emitter that leads to the arrow that leads to the emitter right here is pointing outwards. That is not pointing in. So that indicates that we want an NPN transistor. And in our shop, the standard small signal bipolar junction transistor that we use is the 2N3904. Okay, now on your 2N3904, you've got 3 legs coming off of it, so it's important that you know which leg is which. Right here, you can see on the schematic that I've marked them E, B, and C for emitter, base, and collector. And looking at the transistor with the flat side facing up, so I can read 2N3904 right across there, we can remember that because you say eat, big, cookie. So looking at the pinout of the standard transistor we use in our shop, we go eat big cookie or emitter, base, collector. Now, not every transistor follows the eat big cookie rule, but the transistors that I generally hand out for the projects that you're going to be doing follow the eat big cookie rule. I try to simplify it, but do like to give you a little bit of a heads up that out in the wild world of transistors, things are different out there, and there are other things that look like a transistor that aren't a transistor, and you have to read the invisible ink that they've stamped onto there. So it's always good to have some form of magnifying around. I actually find my cell phone does a good job of illuminating and magnifying those lights so that we can see it. So you'll need 2 of the 2N3904 to give it its full name, the 2N3904 NPN bipolar junction, or BJT, transistor. There's another type of transistors called MOSFETs that we don't use nearly as much in the class. Try to keep things, simple enough. You can worry about the rest when you go on to do your electrical engineering degree. Alrighty, so we've got 2M3904 right there and right there. We've got those picked out, and we know that when you look at the flat side, we've got Eat Big Cookie on there. Okay, down here at the bottom, we've got a diode, and the diodes are just a small little cylinder. And let me bring that up so you can see that little ring on the diode a bit. There is I always describe it as a white ring because back in the day, they used good ink and they made sure that the diodes had a nice white band that was easy to see. But now they kind of use silver or gray or a really, really thin layer of white or something. Anyway, so your diode's going to look something like that, and you're going to have that white band on it. And that white band is important because the diode is also a polarized device, and the white band is what we call the cathode, just like I used that word with the LEDs to indicate the negative side, and the anode is the positive side. So we've got an anode and a cathode, and electricity is going to flow positive to negative through it just like this, and this line right here matches up with this line on the diode. Helps if I focus on that, doesn't it? Sorry about that. Okay, so as I was saying, the diode is going to go through like this. Electricity is coming right down there. So our electricity, our positive supply is going to come in at the top. It's going to flow through here. It's going to come down through the LEDs. The transistors are going to switch it on and off. And the timing of that switching is going to be controlled by the resistor and the capacitor right here. So now we've got to go through and hook all of this up on our breadboard. All right, pardon me for a second there. Okay, so we've got our parts sorted out, and I'm just going to slide my parts off to the side here for a second and click on something unintentionally with my mouse as I do that. And I'm going to bring my breadboard in right here and zoom in on the breadboard. Now I've got the breadboard mounted in my big bad breadboard board, which has a speaker in it, so I can tie it into my siren circuit and all that, but here we go. Now we should be able to see each of those holes nice and clearly so we can talk about where our components are going to be going. Okay, so a couple things about breadboarding is that the breadboard is set up with power strips running along the top. Okay, here we've got a positive, and here we've got a ground, and then we've got these rows of 5 where we come and tie things together right in here. Down here we've got positive, and down here we've got ground. And this is kind of what the breadboard looks like if you rip it open from the back. You can see that we've got a bunch of shiny silver parts right in here. We've got the ones that run the entire length of the breadboard, and we've got these ones that are just 5 segments long right in here. So when you take a look at your board, this segment right here has one of these little segments right in here behind it, and those are just basically wire clips that come up and clip onto your wire and connect whatever wire is plugged in there to any wire that's in there, there, or there. Okay, and importantly, they don't connect to anything else in your circuit. And when you put your positive in right here, the positive runs all the way along the top, and because I've connected this with a wire down to the bottom right here, the positive also runs all the way along the positive and the bottom, and my ground, which is connected here, comes down and connects to my ground right in the bottom here too. Okay, so that's a general function of your breadboard. One thing to note is that some breadboards have a gap right in here. So in the middle of the board, the metal that runs along right in here and the metal that runs right along in here are separated by each other. And if you want, you can just put a wire across there and a wire across there, and you can reconnect them. But that's designed for some more advanced circuits where you want to have 2 different power supplies at different ends of the board. Okay, there we go. Let's take a look at where we're going to start on this. And sometimes it helps if you've got a pair of needle nose pliers for putting some of your components in. They're pretty tiny, so we're not going to need them for this, but they're not bad to have around. And if you haven't already cut your components down to length, using your wire snippers or some flush cutters to get in there. Just some way of cutting those legs. Maybe scissors aren't the best thing to do for that. So here we've got R3 coming off the top of our board, and R3, looking at our schematic, um, you know what? We can actually take a look at that on Falstad. Just let me move some of my paperwork around here off screen and bring up Falstad right here. And so this is going to be our R3 and our R4 right here. And you can see that they're connecting right into our power line. And so I want to connect this to power and I want to connect this to power, but I don't want the downsides of them to connect to anything else. So what I'm going to do is I'm going to drop those into the power line. I'm just going to start down at one end of my board right here. And this should be close enough to the end of the board that I'm not wasting space, but not so close that I end up wasting time trying to be fussy. And I'm going to leave it so that when those go into the board, they've got a little bit of a gap between them. Make sure you get them into the positive line right up here. There we go. And now I've got those two popped into the board. And you'll notice that I make sure that one end goes into the red where my positive's coming in. That one's got an end going into the red. And then down here, I've got this pin right in here. So that's going to connect to anything else that goes into these four holes right here. And this one is going to connect to anything else that goes into these four holes. But because they're in a separate set of 5, they're not connected to each other. Okay, now looking at our schematic again, we can see that on the other side of this resistor, okay, I'm highlighting it in blue right here, just off on the Falstad circuit simulator on the right-hand side of the screen. On the other side of this resistor, we're going to connect to one of our 56K resistors, and we're going to come down here and we're going to connect to an LED. Now we could use wires to make the connection, but and there's nothing wrong with that. In fact, a lot of circuits, it's a really good idea to use wires to spread things out. But the Winky Blink's a fairly simple circuit. We can pack it in pretty tight. So I'm going to have a little bit of fun with this and jam it in here nice and tight and cozy. And to do that, I'm going to take my 56K resistors and put them in right down here. Now, like I say, they don't have to be a 56K resistor. They just control the timing. So you've got some ability to swap those out later on if you want. Try some different resistor values in there. And what you'll see right now is that I've got this lead right here, comes down right here because they're in the same set of 5 holes. They're connected. And then this one's going to come right down here. And because they're in the same set of 5 holes, they're connected. It doesn't matter that it's not in those first 3. The electrons really don't care. They'll travel through the metal and give us a gap. Okay, so now I'm going to pop an LED into the board. And again, with your LEDs, watch for that short leg and the flat side on the LED. So take a look at your LED from the top, get in there nice and focused, and make sure you're finding a flat side on there. And then I'm just going to pop that in right there. And then I'm going to pop it in right here. Just bend it out to the side right now so you can see what I'm doing a little bit. You don't have to bend it out to the side unless you want to. And again, with the red LED, check for your anode and your cathode, your positive and your negative. Don't try cramming more than one device into the same hole. You've got lots of holes in there. And if you cram more than one wire in there, you're just not going to be happy with the results. And I'm just going to bend that out. So there we go. We've got a couple of LEDs stuffed in there. And now our LEDs are hooked up. So again, looking at the schematic, we've got at this point right here, we've got a resistor and a resistor and the cathode, the anode, the positive side of an LED, all joined together. So right here, I've got a resistor, and the positive side of an LED all plugged in together right here. And on this side, I've got a resistor, and the positive side of an LED all plugged in right here. So there we go. We've got about half the board done. I'm going to do the transistors next. And I'm going to do a little bit of a trick with the transistors in order for us to fit things onto the board a little bit more tightly. Now you'll notice if you come down to the transistors and take a look at the transistor right here, that they both have a collector and they both have an emitter. And the emitters, okay, both connect to each other and they connect to the diode. Now, holding the transistor up like this, you can see that the emitter on this one is going to be on the left-hand side, okay, and the collector is going to be on the far right-hand side. So I'm going to take that and I'm going to pop it in here, and let me just get that nice, and I can go right across here. Okay, now I've crammed that in a little bit close, but hopefully it's clear to see that the flat side, okay, is on this side right here. The flat side is pointing down here. And when you look at this, what I've done is I've put one lead into these holes in the middle. You can tell I've done this before because I've left a little space right down the middle. And you know what? If I needed more space, I could bend the leads, I could add some wires or something like that. But I'm walking you through one that's going to work the first time out. So there we go. We've got one lead right in there. Now the second lead right in here, okay, this is our base, and that connects to the 56K resistor. So we're looking right now at the transistor on the right-hand side of the circuit. I've just highlighted it on Falstad. Okay, and you can see that that is connected to our red LED on the right-hand side of the circuit. Okay, and we'll worry about that capacitor later. Our emitter is going to come out right here, but the base comes back and connects to the 56K resistor. That's looking pretty good right in there. I'm just going to stand that up so it's a little bit out of my way. Now, if I want my emitter right here, my base right here, and my collector right there, there's a little trick you can do with your other transistor and flip it around 180 degrees, pop it in right here. So it's facing its friend. So now the flat side that says 3904 is on this side. That means that when I look at it from this side, I say my emitter is right here, my base is right here, and my collector is right here. So this is my emitter connected to the other emitter. This is my base connected to the 56K resistor. And this is my collector connected to the LED. And looking at this transistor on the schematic, this transistor is right over here. Just highlighted it in blue on Falstad. And you can see that the collector comes in to the LED, the base comes in to the 56K resistor, and the emitter connects over here to the other transistor's emitter. So our two emitters meet at a common point in the middle. And that's where we'll pop the diode in, because the diode is going to take the power that comes out of the transistors and drop it into ground. Okay, or the negative side of your circuit. And so I've added the diode, which you see down at the bottom right here. The anode or positive side of the diode is connected right here to the emitters. There's two emitter pins right in here joined together, and it comes down, and I made sure it went into the blue line. I didn't put it into the red line by mistake, as I sometimes do during these demos. And right on here, it's a little difficult to see with the light. Let me just rock that up a little bit. You can see that white or silver line is pointing down towards the baseline, towards the ground line right here. So our electricity can come in at the top, flow all its way through, and then come out this way. And if we ever hook anything up backwards, it can't come right in there and damage our transistors. So that's all looking pretty good. We've got two capacitors left to add to the circuit. And it's the capacitors that always give people grief because it's not that hard. You just need to stop and do it one little step at a time. So take a deep breath, pat yourself on the back, you're doing well. And after a brief meditation about the wonders of electronics, carry on with your capacitors. Now, you'll notice that the capacitor right in here, and I'm highlighting it on the schematic right now, is going to connect from one collector to one base. Okay, there's the base right there. It's going to connect. One side of it is going to go into the line that's got the 56K and the base. So if you want to know where to put that, take a look on your board and say, okay, this capacitor is going to connect to the base of the transistor on the left-hand side of the board. And you'll find that pin by saying transistor on the left-hand side of the board right here, emitter, base, right in this set of rows. Here's your 56K ohm resistor that also connects in there. So you want to put something into this pin right here, and what you want to put in there is the negative side of your capacitor. Okay, notice in the schematic that the positive is pointing the other way. So take a look at your capacitor, say, that's where my negative is, okay, and that's where you're going to put that lead. And it can go into, either of those holes right there. Now, again, calmly, take a look, say, okay, I've got the negative in here. It's connected to the base of this transistor. It's connected to the 56K resistor. The other side is going to come over on the side, and it's going to go into this transistor, the pin where the collector is and where the LED is. So come down here. On this side, we've got emitter, base, collector. There's our collector. There's our LED. And fit your pin in right in there. Now, I'd chop my legs off pretty short on that transistor, and I'm a little bit worried. And this is something you do have to watch for when you're breadboarding, is it looks like it's in the right place and everything, but if I turn it up like this and take a careful look, I'm going to have to focus it for you in a second here, but if I turn in and I look from this angle right here, am I touching this line to that line? Because if those legs touch, the electricity will do a short circuit through the legs and it won't go through the components. Electricity is very lazy. It does not want to do any work. It does not want to go through the components. And if you give it a chance to go somewhere else, it's going to scoot right around there. So always check your components when you're breadboarding to make sure that you don't have any long touching legs in there. Okay, so what I'm going to do to get around that is I'm just going to move it up one space right in there, and it's in the same set of 5 holes, but now it's not quite so close down to that diode, okay? So double check that. In this transistor goes from the base on one side to the collector on the other side. All right, now the next one's going to be a little bit of a tougher fit for us, okay? Because we're running out of space to put things into there. And I've done this slightly different and wired things up a little bit differently last time out. So my legs might, well, they might be long enough. What I'm going to do is I'm going to open up a little gap between the transistors right there by bending them backwards. Okay, I'm going to come back and double check and make sure I'm not touching that diode down at the bottom there. So I've opened up a little bit of a gap in there, and this is going to be our top capacitor, okay, on the circuit. On your schematic diagram, this is going to be called C1. And so C1 is sitting right here. I'm highlighting it in blue, and it is going to come from the base of the capacitor on the right-hand side of the circuit, and it's going to connect over here to the collector on the left-hand side of the circuit. So kind of like we did with the last one, but opposite. You flip it around. Again, negative side, okay, is going to come to the base on the left-hand side. So find that hole, and here's my transistor on the left-hand side, and I go emitter, base, and slide that in right there. And then over on the other side right here, you want to pop it in to the collector on the other side. There we go. We've got everything packed together in there, and it's a little denser than I sometimes like right in here because everything's packed in really tight. You do kind of have to take a look at it from the side and make sure that none of these legs are touching each other, but I think if you followed those steps, you should be pretty good for that. And now what you can do is you can grab your trusty power supply leads and make sure you get them the right way around. Plug them in to your breadboard. This is always the exciting part of the video for me. Does it work? Whew. It's so easy to make one little mistake and get something wrong. So if something's not quite working for you right now and you're not getting blinking, don't panic. Like I say, I've done this 3 times in the last day or two, so I'm up to speed on putting this together. If you're putting this together for your first time, there's a lot of puzzle pieces in there. And the thing about a breadboard is that just as there's a great variety of ways to be creative, there's a great variety of ways to be creative and get it wrong. And don't think of it as wrong. Think of it as a learning exercise. You may, anyway, um, it's blinking. Yay! Well, what do we do with it now that we've got a blinking LED? Well, remember I told you that you could change up that blinking speed by putting different valued capacitors in there, or changing out the resistors right down in here. Those ones are going to be a little bit of a pain. I think these capacitors are going to be the easiest to change. If you look through the kit of parts I've given you, you might have a, this one says 2.2 microfarads on it. Where's my focal point gone? There we go, a 2.2 microfarad capacitor. Again, it's got the negative side mark, different colors, but it's got the minus on it. It's got the short leg on there. Let's try pulling out one of the capacitors that we've got down here. Now, because this is a 2.2 microfarad instead of a 10, one of the LEDs should only stay on for about 1/5 of the time. And we can do this while it's blinking right here. Just make sure that you get it into the right holes. If you've got any doubt, you can power down while you put the new part in. And there you go. So now we've got a much faster blink on one side than on the other. We could also change the capacitor out on this side to make that blink more rapidly. Gonna put the original capacitor back in there. You've got some other styles of capacitor too. Something like this is a film capacitor. There's no positive or negative to it, and it's got 2 leads coming off of it. These ones tend to be very small values. So this one is actually 224, it says on the front. We'll talk about capacitor numbering later on, but that's 220 nanofarads, or 0.2 of a microfarad. So it's going to blink super fast on one side, and I hope that it doesn't blink so fast that we're unable to see it. There we go. It looks like the blue never turns off. That's how fast the red is blinking. We never actually see that change in the blue. Oh, and look at that. It's blinking so fast that the camera is missing it sometimes. I'm seeing it blinking here in real speed, and I think the frame rate is just not quite keeping up with it on the camera. So you've got some other capacitors in there too. If you go for one of the bigger capacitors, this one's 470 microfarads. So this is one of the ones that might actually make it be kind of boring and take forever. So I'm not going to use that one. Go ahead and try it at home. Here's one that we looked at earlier. It says it's 47 microfarads. So now the red one should stay on a little bit longer. And let's see what we can do right here. Plug that in. And now the red one stays on for a long time. Now, other things you can do playing around with this circuit, you can put different capacitors in there. Make sure I put this one in and back in and get it the right way around. You can put different capacitors in there. Now, if you wanted more LEDs in there, you can put more LEDs in and double up your LEDs. You'll find some interesting things start to happen when you do that. Let's see. First of all, I run into a little bit of a problem finding a hole to plug this into. I've got to jump all the way right down there, but you can now have multiple LEDs blinking on each side. One interesting thing to try is try hooking up a red LED and a blue LED on the same side. Find a hole for this one. Hole down there to plug it into. And you'll notice that the blue LED doesn't always come on. In fact, quite often it won't. And that's because electricity is lazy, and it's a lot easier for electricity to get through a red LED than it is through a blue LED. That's got to do with the nature of how the LEDs generate light, and red, green, and yellow LEDs only need a very little voltage to turn on, but blue and white LEDs need quite a bit of voltage to turn on. So there we go. You've got a Winky Blink circuit put together on your breadboard. Leave it on your breadboard for now. When you come back later, I'm going to show you something called Protoboard, which is a pre-printed printed circuit board that has holes exactly like your breadboard does. So you'll be able to take each of these components off and solder it onto a printed circuit board and maintain it for posterity, and forever and ever you'll have your very first Winky Blink. Next up, the siren. I don't know if you heard that. Siren's going. What did I do there? Siren.